Hi, my name is Alyssa Brewer, and today is October 1st. My presentation is on neural reflexes in the gut, short versus long pathways, specifically exploring enteric coordination and communication. Today, I'll be walking you through the neural coordination of digestion, focusing on short and long reflexes of the enteric nervous system. These reflexes are essential for regulating motility and secretion, two of the most tightly controlled processes in the GI tract, as noted in our textbook, Silverthorne, Chapter 21.3. We'll explore how the gut communicates locally and with the brain, and how this coordination ensures proper digestion. Let's dive into the second brain of the body, the enteric nervous system. The enteric nervous system, or ENS, is a dense network of neurons embedded in the walls of the GI tract. It contains over 100 million neurons, more than the spinal cord, and can function independently of the nervous system. Silverthorne describes how isolated gut segments can generate peristaltic waves when stretched even outside the body. This shows that the ENS can integrate and execute reflexes on its own. Structurally, the ENS resembles the CNS. It has intrinsic neurons, glial cells similar to astrocytes, and a diffusion barrier like the blood-brain barrier. It also uses over 30 neurotransmitters, including serotonin and nitric oxide. Think of the ENS as a local command center. Like a sea anemone's nerve net, it senses, integrates, and responds without needing a brain. Short reflexes are entirely contained within the ENS. They begin, integrate, and end in the gut wall. Sensory neurons in the submucosal plexus detect stimuli like stretch, pH, or nutrient presence. This information is processed locally, and motor neurons trigger responses such as secretion or muscle contraction. The submucosal plexus controls secretion, while the meninteric plexus regulates motility. These reflexes are fast and efficient, like texting your neighbor instead of calling headquarters. They allow the gut to respond immediately to local changes. Long reflexes involve the central nervous system. Sensory signals from the gut travel to the brain or spinal cord, where they're integrated and sent back via the autonomic neurons. These reflexes can be triggered by internal stimuli, like gut stretch, or external cues, such as the sight or smell of food. Silverthorne calls these cephalic reflexes. For example, smelling dinner can trigger salivation and gastric secretion before you even eat. Emotions also influence long reflexes. Think butterflies in your stomach or stress-induced diarrhea. Parasympathetic signals, mainly via the vagus nerve, enhance GI function. Sympathetic signals inhibit it. These reflexes coordinate digestion across regions, like a manager sending instructions to multiple departments. Let's compare short and long reflexes side by side. Short reflexes originate and integrate within the ENS. They're fast, localized, and respond to stimuli inside the GI tract. Long reflexes involve the CNS, integrating broader signals and coordinating across regions. For example, segmental peristalsis is a short reflex, while gastric secretion triggered by food anticipation is a long reflex. This table helps to clarify their differences in origin, pathway, and function. It's a great reference for you later on. Understanding these reflexes has clinical importance. Disruptions in the ENS signaling are linked to disorders like irritable bowel syndrome, where motility and secretion become dysregulated. The gut-brain axis shows how emotions and stress can influence digestion. GI peptides like CCK and ghrelin also modulate reflexes. CCK promotes satiety and is found in both the gut and brain. Ghrelin increases hunger and acts on the brain. Silverthorne highlights how these peptides can act as hormones, neurotransmitters, and paracrine signals. Regulating motility and secretion ensures proper digestion. Too fast and nutrients aren't absorbed, too slow and food stagnates. Let's finish with a case study that brings everything together. Meet Maya, a 26-year-old graduate student who reports that her stomach flips before exams and she gets cramps after eating. She experiences bloating, alternating constipation and diarrhea, and her symptoms worsen when she's stressed or rushed. Her labs and imaging are normal, but she finds relief with mindfulness and deep breathing. So what's going on? Maya's pre-meal symptoms like stomach flipping are classic long reflexes, specifically cephalic and emotional reflexes integrated in the CNS. These are triggered by external stimuli like stress and anticipation, and they activate atomic pathways that influence gut function. Her post-meal cramps may involve short reflexes, local ENS responses to stretch and chemical changes in the lumen. If her ENS is hypersensitive, even normal digestion could trigger exaggerated motility or secretion. The sympathetic nervous system is likely overactive in her case, inhibiting normal GI function, and peptides like CCK and ghrelin may be contributing to her symptoms by modulating satiety and hunger signals between the gut and brain. This is the answer key to it. I forgot to put just the case study. So your task is to analyze Maya's case using what you've learned, identify the reflex types, neural pathways, and suggest strategies to help regulate her symptoms. And then that's the answer key, and here are my resources. Thank you.